Hey guys, so this is homework 7.3b, and today we're going to talk about identities. An identity is an equation that is true for all values. So have you ever been solving an equation, like for example, the equation I'm writing now, 6x plus 5 minus 2x equals 4 plus 4x plus 1. So have you ever been solving it, and what ends up happening is that you get kind of the same thing on both sides and you maybe think it's weird, but then you keep going. And then when you end up not actually solving for a value of x, but you end up just getting the same thing on both sides of the equation. What this means is actually that this is an identity. It means that no matter what value of x you were to put in, it would make both sides of the equation equal. So an identity, again, is really just an equation that's true no matter what value you substitute in for x. So sometimes in this course, you may be asked to prove an identity, and it's actually not as hard. So let's take a look at an example. So here is an identity that actually we've used a lot in this class, and it is x squared minus y squared equals x minus y times x plus y. So we've used this before as a method of factoring, and we call it difference of perfect squares. Usually we have like a number in place of y squared. So anyway, if we're being asked to prove how this or why this identity is true, all we really have to do is either simplify one side or expand the other side to make it so that both sides look exactly the same. So I'm going to just simplify the right side of this because that looks easy to me. So I'm going to multiply out x times x is x squared, x times y is plus xy, and then negative y times x is minus xy, and negative y times y is negative y squared. And I'm going to keep the other side of the equation just as it is. Okay, so now I can simplify the right side even further because the positive xy and the negative xy just add to 0. So on the left side, it's x squared minus y squared, and on the right side, it's x squared minus y squared. There you go. We just proved this identity to be true. And again, an identity means no matter what values we plug in for x and y, the equation will always be true. Let's prove another identity. Let's take the identity a plus b squared equals a squared plus 2ab plus b squared. And again, we're going to prove that this identity is true. So what that means again is I'm just going to take one side of the equation and I'm going to expand it or simplify it so that both sides look exactly the same. If I look at the right side of the equation, there's really nothing I can do to expand it or simplify it. But the right side of the equation, I can definitely write a plus b out 2 times and multiply it together. So that's what I'm going to do. A plus b quantity squared really means a plus b times itself. Whoops. Okay, so we have a plus b times a plus b, and we just want to see that it's going to equal what we have on the other side there. Okay, let me try this one more time. So we want to see that it's going to equal a squared plus 2ab plus b squared, and once we get both sides to look like that, that means we've proved the identity to be true. So I'm going to expand the left side. A times a is a squared, a times b is positive ab, again b times a is positive ab, and b times b is positive b squared. And the other side of the equation stays the same. Okay, on the left side I have a little bit more simplifying to do because I see like terms. I have 1ab plus 1ab, which is 2ab. So the left side simplifies to a squared plus 2ab plus b squared. And the other side is a squared plus 2ab plus b squared. So there we go. We've simplified the left side, and in turn we've proved that this identity is true by making the left and the right side look exactly the same. That's all for now. See you guys tomorrow. What do you think?